we will learn regarding Snell's law. Okay. So Snell's law, basically it explains how light waves change direction when passing through one medium to another medium. Okay. So let me take another color and explain you. So let's have one with a air medium and other as a glass medium. Okay. For example, now, so this is the normal or perpendicular to the surface I'm drawing. So this line is called as a normal line. And when incident light, okay, when it falls, and this gets reflected, so this is the reflected light, this is the incident light. Now when it enters the medium and it bends, so this is the refracted light. Now let's consider this is different angles. So this is your, so angle of incidence is also equal to angle of reflection. So here theta 1 will be equal to theta 2. So this is the law of reflection. So along the normal, both the angle of incident is equal to angle of reflection. So this is basically your Snell's law. Okay. So mathematical formula that explains along with the angle. So this is basically, I'll just make it a note. So mathematically, it's written as n1 sine theta 1 is equal to n2 sine theta 2, where n1 and n2 I already explained you. These are the refractive indexes of the two different media. Okay, one is this media, air media and glass media, for example. And theta 1 I already told you, this is the angle of incidence. Okay, so, and theta 2 is your angle of, this one is your theta 2. Sorry, these both are anyway same, so you can write theta 1. So here this is theta 1. Since both angles are same, I am again rewriting it. Both are theta 1 only, angle of incidence. So here we are basically defining between your angle of reflection or angle of incidence versus your angle of refraction. So this is mathematically given by your Snell's law, how the angle of refraction is happening. Okay. Now Snell's law in case of optical fiber, that basically determines whether the light is refracted into the fiber core or reflected away. Okay. Now for that we also need to learn regarding something called as a numerical aperture. Okay. So that we will discuss later. So in case of like practice, light source must be aligned in the fiber acceptance cone. So we have this, as I explained you before, the fiber will look something like this. So this is the total core size that we have. Okay. So fiber must be entering in this particular cone. Obviously if it enters in different angle, it won't enter the fiber. Okay. So that is defined by your numerical aperture. So the minimize the insertion loss or prevent any unwanted refraction. So for that you have to follow this n1 sine theta 1 is equal to n2 sine theta 2. Okay, where theta 2 is your angle of refraction along the normal. Okay, remember both the incident light and reflected light, obviously they will have the same angle. So I have written again that both are theta 1, and I have defined the theta 2 as the refracted light angle. So this is basically your Snell's law.